pKa is the first in a cascade of enzymes that lead to the breakdown of glycogen to glucose and to the production of cellular energy by way of glycolysis. When activated by the presence of cyclic AMP, which is produced in response to hormonal stimulation, pKa catalyzes the phosphorylation of phosphorylase kinase. Phosphorylase kinase is a complex of 4 subunits, designated alpha, beta, gamma, and delta. Prior to its phosphorylation by pKa, and in the absence of calcium ions, phosphorylase kinase is relatively inactive. The catalytic subunit is the gamma chain, which is shown here. It is inactive in large part because its C-terminal tail, which resembles the enzyme's polypeptide substrate, binds in this enzyme's active site. This pseudosubstrate thereby blocks the access of true substrate polypeptides to the active site. The inhibitory polypeptide shown here has a sequence similar to that of the pseudosubstrate, and presumably binds to the gamma subunit in a similar way. Phosphorylase kinase becomes fully active only when its alpha and beta subunits have been phosphorylated by cyclic AMP-dependent protein kinase and in the presence of calcium ions. Calcium ions induce a conformational change in the delta subunit, which is known as Calmodulin, which then binds to and extracts the pseudosubstrate from the active site of the gamma subunit. The mechanism by which the phosphorylation of the alpha and beta subunits activates the enzyme is unknown. In the presence of both calcium ions and its target polypeptide, Calmodulin undergoes a change in conformation that permits it to extract its target polypeptide from the active site of the gamma subunit of phosphorylase kinase, thereby activating this kinase. Glycogen phosphorylase is regulated both by being phosphorylated itself and through allosteric effects. The unphosphorylated or B form is more stable in catalytic inactive T conformation. Physiological levels of the inhibitors ATP and glucose 6-phosphate allosterically stabilize this conformation. Only the T state can be phosphorylated by phosphorylase kinase. The activator AMP binds tightly to the R state, thereby allosterically activating the enzyme. The B form of the glycogen phosphorylase is activated by the phosphorylase kinase catalyzed phosphorylation of its serine 14 to yield the more active A form of the enzyme. Under most conditions, the R state of glycogen phosphorylase A is its predominant form. However, high concentration of glucose allosterically shift phosphorylase A back to the T state, thus regulating the activity of this enzyme through negative feedback. Phosphoprotein Phosphatase-1 inhibits the breakdown of glycogen to glucose by removing the phosphate groups from both glycogen phosphorylase B and phosphorylase kinase.